We got to get you your 5 million for doubling the penny. So we have this right here is called the J curve. Yesterday, we said the J curve started at 0, 1. So we plotted that first point at 0, 1. And that's because if you plug 0 in, listen to me carefully. I'm good. Thank you. Anything to the 0 power is what? Is 1. Anything to the 0 power is 1. Okay, listen to me carefully. If I put 0 in, anything to the 0 power is 1. 2 to the 0 power is 1. So 2 to the 0 power is 1. Then we went down here and they had 1, 2. If I plug 1 in, you got to pay attention. 2 to the first. What's 2 to the first power? Just 2. So that's why we have the point 1, 2. Because I plugged 1 in and I got 2. What if I plug 2 in? What are you going to get? What's 2 to the second power? 4. 2 to the second power is 4. What if I plug 3 in? What's 2 to the third power? 8. 2 times 2 times 2 is 8. Let's go one more. What's 2 to the fourth power? 16. Okay? Now, what happens on this side is interesting, and you just need to learn this. Okay? It flattens out, and here's why. Because as soon as I start putting, please stop. As soon as I start putting negative numbers in, and we'll learn this later, but a negative number, what it will actually do, everybody take your calculator right now and put 2 to the negative 1 power. Put 2 to the negative 1 power. 2 to the...
It equals 0.5.
It equals 0.5. Now math fracket. Do it right now, James. Do 2 to the negative 1 power. No, 1/2. Okay?
I got 1/2.
Yep, 1/2 is correct. If I do 2 to the negative 1 power, 2 to the negative 1 power, I get 0.5. Now go 2 to the negative 2, and let's see if you can figure out what happens. 2 to the negative 2, what do you get? 0.25. Math frack it real quick. Math frack. What do you get? 1/4. Let's go 2 to the negative 3. See if you can figure out what's happened. I get 0.125. Math frack it.
It'll never touch 0.
Never touches 0. It keeps getting closer. Go to 2 to the negative 100 power. 2 to the negative 100 power.
And you can't frack it.
You can't math frack it either. All right, here's why. Because the number's so big. Here's what's happening. This negative exponent, what it does is it sends the 2 to the 100 power to the denominator. Listen to me carefully. This is new. 2 to the negative 100, it takes the negative exponent, sends it to the denominator, and it's really 2 to the 100 power in the denominator. 2 to the negative 3 was really 2 to the third on bottom. 2 to the negative 2 was really 2 to the second on bottom, which is why it's 1/4, because 2 squared is 4. 2 to the negative 3. Why is it 1/8? Because 2 to the third goes to the bottom. 2 to the negative 1. Why was it 1/2? Because 2 to the negative 1 goes to the bottom, becomes 2. So it becomes 1/2. When that happens, he said it's never going to get to 0. Look at this number. How many of you got this number right here on your calculator? This E negative 31, look up here. This E negative 31 means move the decimal 31 places which way?
To the left.
To the left. So you'd move it once. Watch this. E negative 31. That's times 10 to the negative 31st power. It's called scientific notation. How many of you have seen scientific notation in science class? Where they have like 10 times 10 to the negative 23rd, or times 10 to the 4th, or times 10 to the 18th, or like they're measuring distance from stars, or distance to atoms in a molecule. And if this is like represents a really, really small number, because what Daphne would have to do is Daphne would have to move the decimal 31 places to the left. So what I would do is move it once, and then I'd have to move it 30 more times. So how many zeros would there be? It'd be 0.0 how many times?
31.
Nope, I already moved it once for the 0.7.
30.
30 zeros, then 7, and then your decimal point. Okay? So it would literally move it over 31 times. So you'd have 0.0 30 times, and then you would get to the 7. And then you'd have 0.00000000000 30 times, and then 7888, blah, blah, blah. That's an extremely small number. Okay? So with that said, the reason this graph is flattening out towards 0 is when you use negative exponents, it's getting sent to the bottom of the fraction. So everybody write this in the margin. If you have 2 to the negative 1, that's really 1/2. Write this down. Write this down.
Oh.
Just write it there in the margin. Okay? Make sure your headphones are out. Okay? If I have 2 to the negative 2, that's really over 1 over 2 squared, which is really 1 what? 4th. And that's 0.25. Somebody tell me 2 to the negative 3, what would that be? What would that be? 1/8. 1 over 2 to the 3rd. That's exactly right, James. 1/8. What would 2 to the negative 4 be? Anybody want to take a stab at that one? 1 over 2 to the 4th, which is 1/16. What's happening? These fractions are getting smaller and 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 smaller, which means it's just going to keep getting closer to what? 0. That's why it flattens out. Now, Joe and I will be able to relate to this. It's like paying off your house. It never feels like you're going to get to 0. When you're paying off a loan, this is the direction the payoff happens. You keep paying it off and 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 paying it off. And it doesn't ever feel like you're going to get to 0 because you're paying that thing off for 30 years. In fact, when you get to the end of your loan, you actually don't pay it off. If you followed the curve, you never would pay it off, and that's what the bank wants. But what you do is at the very end, when you get really close to the end, they'll start saying, here's what your payoff amount is. And so then if you finally want to take it to 0, you just have to send a check in or go online and do a deposit and pay it off. Because if you follow the curve, you actually never get to what?
0.
You'll never get to 0. That is called something. You ready? It is called an asymptote. Okay? And these asymptotes are bad asymptotes. Okay? Oh, look, I got Maya to smile. Okay? They're called asymptotes. An asymptote is simply a line that you approach, but you never what? No, you never
cross.
You never cross it. You never touch it. Everybody say it with me. It's a line you approach, but you never what?
Cross.
You never touch it. Now, where is this used in the real world? Asymptotes are used everywhere. It's what, in fact, DNR uses an asymptote because they limit deer population.
What's going on with the shirt under that shirt?
They made it for me, my cross-country team, based on this number right here. We're only going to have pie if you're good and you're listening. Thank you so much. I got Swiss cake rolls and oatmeal pie. How's that sound? Okay? Everybody's excited right now. Look, Javier just popped up, man. He was sleeping 2 seconds ago. He heard Swiss cake roll, man, and the kid woke up. Good gravy. I've never seen you so alive, Javier. Okay? All right. So, anyways, negative exponents. So that's just approaching 0. So an asymptote is a line the graph approaches but never touches. So let me go to Miles' example of like deer population, moose population. Based on how much land there is and what else? Acreage. And how much, what else? Like to limit deer population. Deer population is not going to grow exponentially. It's not just going to go up forever. In fact, deer population looks like this. Watch. This is what a graph of deer population is. It's called a logistics curve. Okay? There's actually an asymptote here. And then there's an asymptote here. And deer population, because deer will just keep having babies. So they'll grow like the penny. They'll just keep having babies. Okay? Keep populating. Okay? So what happens is you get like a J curve, but then eventually, because of how much land you have, and what else?
Hunting.
Because of predators, what else?
Hunting.
The winters, what else?
Food.
Food, what else? How much access to water, food, shelter? What's going to happen? Disease. What's going to happen to the population?
It's going to drop.
It's going to flatten out. And based on, the DNR will calculate based on regions, they'll say this is what the optimal population of deer is in this section. And so you know how they divide up the deer population map every year when you go buy your deer license and you say, I'm in this what?
Region.
I'm in this region. Do they call it regions or do they call it, what is it?
Is it zone?
A zone, yep.
In an area.
Yep, a zone in an area. And so they'll go that zone in the area, and the DNR has said, we think, and it's crazy, they use statistics to do it because they tag deer, and they estimate how many deer are in that area based on how frequent they see that tag based on some statistics formulas. And they can say, and here's the craziest thing, they actually use this in World War II. The way they tag deer is the same way they figured out how many tanks there were in World War II. And a mathematician did it over here, and they did better than our intelligence on the ground actually in Germany. Because what Germany were doing, they were trying to trick the intelligence on the ground, and what they were doing is they were taking tanks, and they were taking the tanks and sending them out, and they were taking the same tank, and they were just changing the license tag on it. A guy figured out they were doing that, and he used a statistical formula, and the intelligence told the Americans, they have like 12,000 tanks. And the guy sitting in a university in America said, no, they only have 996 tanks left. Do you know how many they had left? 997. He got within one using a stats formula. And over there, they were counting, like they were intelligence on the ground, and they estimated there to be 12,000. But this guy over here used the math formula and only got one away. They do the same thing that they estimated the number of tanks in World War II to estimate the number of deers there are in certain zones. They use a statistical formula. And they can get within probably 5 deer, even though they're only tagging a few. And it's just how frequent they see it. And they use this crazy stats formula to get close. And then they say, based on that zone, we think the best population of deer is 1,000. Because once they get above 1,000 deer, what starts to happen?
Drop.
They start to drop. Why does it drop? Not enough disease. If you get too many deer and you get overpopulated, there's less food, there's less water, and then they start to disease, and it kills off the population. So what do they do every year in deer hunting per zone to help control the population? No, feeding would make them populate more.
More tags.
More tags. If they feel like an area is overpopulated, they'll open it up for more tags. And then every now and then they'll let people go into the national parks or the state parks, and they'll open it up for a couple, and they'll say, Miles, you can come in, shoot 2 deer, because they want to control the population. Because if the population goes above this line, even though it's exponential, because if we don't control it, here's what's going to happen. Deer are going to keep having more deer. And then what's going to happen? There's not going to be enough food, and what's going to happen to the population? It's going to drop. We kill off our population. Okay, and then over here, it approaches what? If there's not enough food. Not enough land, not enough resources. What's the population going to approach?
Zero.
The population can become extinct. And so it's kind of wild, girls. Okay? So pretty cool. This is why that exponential function can be used in the real world. Now, we don't want our money. Remember we said, and I'm going to give you this document next week. We don't want our money to tail off. What do we want it to do? We want it to keep on growing, keep on growing, Don't write notes to each other on the calculator. Is my conversation about math not that interesting about deer? Javier perked up, okay? All right. So, last thing. So here's how you're going to tell. Let's review, and then let's go to the examples. And then I'll get you going to your homework, and you can eat pie. Here we go. All right. Here's what I have. So let's review. I need everybody's focus. Linear. Linear goes up. When you look at the table today, you're going to tell it's linear because it goes up by the same amount every time. Everybody tell me, linear does what? Same amount every time. Quadratic, listen, quadratic's going to have a pattern. Quit making fun of my tattoo. Quadratic goes up by a certain pattern. But then when you look at the pattern that it goes, I got a turtle on my ankle, yes, okay? The turtle and the hare. Remember I told you the story. Slow and steady wins the what?
Right.
No, it's not farting. That's smoke. Okay? Crystal thinks my turtle's passing gas here. All right? Here we go. So we got 1, 3, 5, 7, 9. Now look. Okay, focus now. What's the second difference, though? The second difference is the same. So when you find the pattern, If the second difference is the same, you know it's quadratic. Okay, let's review. Linear, it's just what? Nope, stop. Linear, it's just what? The same every time. Quadratic, there's going to be a pattern, but then when you find the second difference, it's same. Now, exponential is the easiest one. The exponential doesn't add at all. It multiplies. So look at the pattern. So as these go up by 1, and I really don't care about these. As these go up by 1, everybody write it.
The bottom goes up by.
The bottom is not going up. It's timesing. This one will be the E. It's getting times by 2 every time. Times 2. So exponential will be easy because it's the only one that does multiplication. In mathematics, there is nothing more powerful than an exponential function. That's why you want your money to grow exponentially. When they say something goes up, how many of you have ever heard it said, oh, gosh, it just went up exponentially this year. My taxes went up exponentially. Me and Joe probably looked at our property taxes. Alexis probably looked at her taxes. They're like, oh my gosh, property taxes, they just went up exponentially this year. Because they went way up. They got like multiplied by this huge number. It's not just adding on. It goes up by a certain percentage every year. It gets multiplied by that percentage every year, and they increase your taxes on your property. Or you could go to like Tennessee where they have no property tax. Tennessee has no property tax right now. Ohio's considering no property tax. Florida's getting rid of their property tax. I'm going to move to one of those states. Okay, so exponential. Given a constant change in x, there's a common ratio in y, continuously multiplying by the same number. All right, let's go to the next page. We're going to do the examples. Here we go. All right, here we go.
What page is it?
All right, page 2. Go in order. All right, we're going to do this quick because I've covered it. All right, linear is y equals mx plus b. Let's just review what we did yesterday. M is the slope. Everybody remember M is the what? Slope. Slope-de-dope. If the slope is positive, how would you draw the line? Uphill or downhill? Uphill. So the line's going to look like this. Everybody draw an uphill line. Draw an uphill line.
It's also going down.
You're going to like this chapter because it's a lot of drawing, it's a lot of just looking at things.
It also goes down.
And if the slope is negative, less than 0,
Go down.
goes down.
Yeah, I go with.
Okay? So this is negative. If you want to put a NEG for negative and a POS for positive. Okay? Positive, negative. Okay? All right, here we go. Quadratic. What was the formula for quadratic? AX squared plus BX plus C. And these are our U's. When A was greater than 0, remember which way did the U go? Up or down?
Up.
Up. So draw a U up. I actually don't care where you put the U. You can put the U anywhere. You can put it here. Just put a U up. Doesn't matter. What if A is less than 0?
They go down.
The U is down. All right? Okay? And again, A greater than 0 is positive. A less than 0 is negative.
I just put more or less.
That's fine. More or less. That's fine. All right? Exponential. This was the new one. Y equals A times B to the X. All right. And it has to do with B. No, I'm good. I got it. Thank you, though. Absolute value of B is greater than 1. If this number right here, don't worry about the absolute value. That's just meaning it can't be positive. Or sorry, it can't be negative. If that number is bigger than 1, this is how you want your money to grow. So if it's like 2 to the X, 3 to the X, 4 to the X, 5 to the X, 1.2 to the X, anything bigger than 1 here. 1.3 would be like 30% growth. 1.2 would be 20% growth. 1.4 would be 40% growth. 1.5 would be 1.7, 1.8, 1.9. What's 2 to the X? 100% growth. That means you're doubling. You get 100% of what you got. So if she puts $100 in, she gets $100 back. So now she has $200. And now she's growing her $200. So if she puts that $200 in next month, she gets another $200. So now she has $400. And then the next month, $400 becomes 800. Then 800 becomes?
1600.
And that thing's going to start to grow. The faster it grows, the faster it goes. Okay, that's what you want. If this is bigger than 1, we're going to draw a J-curve. Ready? J-curve, growth. Put J-curve.
J.
So what you do is you start it at 0, 1, and you just draw a J. Up to the right, approach the asymptote to the left. Remember? That thing's going to zero out. It's going to approach 0. Me and Joe are never paying our house off. Have you paid yours out yet? You did? Wasn't that the best feeling ever? I got 8 years left, and I'll be done. All right, this from 0 to 1, decay. This is an L curve. So all we do is we flip it around. Flip that baby around. L curve. All right, are we ready to try examples?
Yeah.
All right, here we go. All you got to do is tell me, is it linear, quadratic, and if it's exponential, you got to tell me growth or decay. So this one's easy. Is it mx plus b? Is it ax squared plus bx plus c? Or is it b to the x power? It is what? Mx plus b. So it's linear, right? Linear. And I'm going to tell you the key is linear. It's just x. It's plain old x to the first power. It's just plain old x. That's all you have to do. All right. Number 2, 5 to the x power.
Quadratic.
It is exponential. Good job, Daphne. Now, exponential, you got to tell me growth or decay. Is this number bigger than 1 or is it? It's growth. So it's you can do this. You can put exp for exponential. You don't have to write the whole word. exp for exponential, and you can write growth. I'm going to do 6 of them with you. No, you got to write growth. I'm letting you abbreviate exponential. You can write growth. All right. Number 3, linear, quadratic. Why is it quadratic? The x squared.
Quad.
You can put quadratic.
So every time it's x squared, it's quadratic.
Yep, every time it's x squared, it's quadratic. Very good. All right, write down what you think for number 4.
What if it's parentheses?
Yeah, what if it's
All right.
parentheses
And then a second square.
All right, my question is there a plane x by itself?
Yes.
No, not in an exponent. Is there a plane x not in an exponent?
No.
It's exponential.
So this is exponential. Anytime the x is in the exponent, it's duh. Anytime the x is in the exponent, it's what, everybody? Exponential. Now, is this growth or decay? Look at it. It's 1/4 to the x. Decay. So if it's less than 1, 1/4 is less than 1. So this is decay. So this is going to be an L curve. If you don't want to put decay, you can put L curve. If you don't want to put growth, you can put J curve. I'll let you do decay or L curve. I'll let you do growth or J curve. You can do either or. Is that okay? All right. Now, number 5 is tricky because it's not simplified. Go back to 2 chapters ago. What do you have to do to this? You got to foil it. All right, foil it real quick. It's not hard. What are you going to get when you foil it? X squared. Stop. What is it? Linear or quadratic? Linear or quadratic? It's got an x squared. It's quadratic. You don't even have to foil the whole thing. Once you see the x squared, you can be like, oh, it's quadratic. Now, could we foil the whole thing?
Yeah.
All right, for kicks and giggles, I'm going to make Miles foil the whole thing. Okay, for the pie. Right now, he earns the pie for the class.
X squared.
Uh-huh.
X plus 7.
So plus 7x.
Yeah.
Okay. Did you take the first term times both?
Yeah.
All right, now you got to take the second term times both. So what are you going to get?
2x.
Negative 2x. Good.
And then 14.
Minus 14. Excellent job. So then this would simplify to, for the official, I'll have Alexis come give you a pie or oatmeal cookie. X squared, what is it, everybody? Plus 5x minus 14. So is that clearly quadratic? Yeah, definitely. All right, number 6, raise your hand if you can tell me if this one is a plain x, or is it to the x power, or is it x squared? Go ahead.
I'm gonna say quadratic.
Is it x squared?
No.
No.
9.
Linear. It is linear. Very good. It's just plain x to the first power. Right now, what I want you to do is do the next 6 on your own. Go.
Wait, Morris, is number
Next
12
6. Go.
quadratic?
And I'll come and hand you a pie or... Huh?
Morris, is number 12 quadratic?
No. Does it have an x squared?
No.
Does it have an x power?
It's one.
Then it's linear. Are y'all doing it? Go. No, don't be mean.
Morris, how long are we gonna be there for?
Wow.
Is it? I heard people say it's gonna go to 9. For real?
Yeah, I might put you in a 4x4.
Like for real, actually? What 4x4 would I be with though?
One of the guys' teams. I'll just throw you in there. You're an alternate right now.
I am.
For one of the teams in case somebody gets hurt.
Who put me in the 400?
All right, here we go. Number 7. As soon as I hand out, you pick a Swiss cake roll or an oatmeal cookie.
I pick both.
No, just one. I like the oatmeal cookies, I'm not going to lie.
Me too.
Make sure Joe and Alexis get one.
Morris, is number 9 quadratic then?
Uh-huh.
Okay.
Yep, because you would end up foiling it.
I have Thank you.
You're welcome.
And number 11 is quadratic too.
Did you get one, Maya?
Squared.
Got one?
Wait, Morris. Number 11?
Yeah.
Is that quadratic too because of that x? Or is that?
Well, because, yeah, number 11,
Yeah.
that would be to the x power. So that would be what? It's an x in the exponent.
So the
X.
Exponential.
There you go. All right, who wants number 7? Maya and Crystal, take a stab at it. Exponential is correct. Now, you have to figure out, is it growth or decay? So it's 3 halves to the x power. Is 3 halves bigger than 1 or smaller than 1? Bigger. So what is it, growth or decay? Growth, very good. You can put growth or you can put J curve. It's not both. Don't worry about the 1/4. Ignore the 1/4. I know what everybody's looking at. You only got to look at the part that's raised to the x power. Number 8, y equals 6. Now, this one's a little tricky. This is a line. It is linear. Now, some people are like, well, wait a second, there's no x. Well, that's like x to the 0 power. No x, that's fine. It's a line. It's actually a horizontal line. If you want to write, this is actually a horizontal line. It's horizontal.
Exponential.
Nope. Listen, I'm going to tell you the keys. If you don't have an x squared, it can't be quadratic. If you don't have an x and an exponent, it can't be exponential. So then it has to be what? Listen, if it's not quadratic, if it's not exponential, it has to be what? Linear. All right, number 9. Let's go with Bella. What do you think? It is quadratic. This is good. I'm impressed. Here's what you have to end up doing. You have to end up doing x plus 3 times x plus 3. If you foiled this, are you going to end up with an x squared?
Yeah.
Yes, you will. This is quadratic. Quadratic. Very good. I'm impressed. All right, number 10. This one's trick. I'll be impressed if anybody gets it.
I got
Aiden, what do you think?
No, that's
I got line.
quadratic.
I got line.
What do you think, Aiden?
Line.
Nope.
Quadratic.
It is quadratic. This one's a trick question. Put a star by it. Here's the problem. Do you see the x on bottom?
Yeah.
How do you get rid of the x on bottom? Times both sides by x. Now watch what happens. I'm going to times both sides by x.
X squared.
Those x's cancel on this side. Do you see it? But then you got to distribute this. What's x times x?
X squared.
X squared plus
1.
x. So it is quadratic. That's a trick question. Okay? Number 11. Go ahead.
Wouldn't it be X?
Javier, are you sitting up?
X, but
Did you go on a sugar down or what? Exponential what?
And then it would be growth because it's 6 over 1.
Exponential growth. Because you look at the 6, you look at what's raised to the exponent, you ignore the 1/2. Ignore the 1/2. That's just where it starts at. Okay, we'll talk about that later. Exponential growth. So this is a J-curve. J-curve. And then finally, number 12. That's definitely a line. Linear.
I think
Okay.
actually-
Now we'll do the last part today, tables and graphs. And then we'll call it good. I'm going to show you how to do a couple of graphs. These are easy. The picture's easy. Okay? It says classify each graph as linear, quadratic, exponential growth, exponential decay, or none of the above. Let's fly through the graphs. Raise your hand on 13. Go ahead, James. Exponential, which one? Growth.
Wait,
J-curve.
Where'd you get 13 at?
Same page.
Oh, it is.
See it, the graph?
Oh.
Got it? J-curve. And people always say, how do I know the difference between a J-curve and an L-curve? I don't know. How do you draw the letter J?
Sometimes I'm just.
Okay. How do you draw the letter L? That's definitely a J-curve. And another reason is your money going up or is it going down? Up is growth. L is the loser curve. You don't want your money to go down. You don't want to lose money. All right. What about number 14? Raise your hand if you can tell me 14. Go ahead, James. Linear. All right, somebody else. Number 15. Raise your hand. Go ahead. Miles. Quadratic. You like this stuff? It's pretty easy, isn't it?
Is there any exponential?
Quadratic. Okay. All right, number 16. Is it linear, quadratic, exponential growth or decay, or none?
None.
This is none. It's none. It's there's other things. It's actually called a polynomial, but we're not going to worry about that.
Line.
17. What is it, everybody? Line.
And then L curve.
Hold on. Let everybody catch up. 17 is linear. Do you agree? It's a line. 18 is a what?
Is that L curve?
L curve. Yes. Exponential decay. L curve. And think of decay as decrease. L curve is the L. Very good. Very good.
Wait, could you just put L curve? Or do you have to put exponential decay?
You can put exponential L curve or exponential decay. You have to put
I
EXP.
just put L curve.
You put also EXP. All right. Last thing. And then this is your homework. I'm only going to have you finish up to page 24. I'll do 3 with you. Okay? Now remember, guys. Linear, they're going up by the same every time. So this is going up 1, up 1, up 1, up 1. Do you see it?
Yeah.
Quadratic, there's a pattern. Guys, stop. This goes up from -3 to 5. How much did that go up? Can anybody figure out how much it went up from -3 to 5?
8.
Went up 8. From 5 to 9.
3, 4.
Went up 4.
0.
0. Then it went up
3. 4.
4 again.
Negative.
All right, now, this is what you need to look. There's a second difference. They're not going up by the same every time, are they? But then if you look at that second difference, what's happening?
They're going down by 4.
Down by 4 every time. And then what? Up by 4 every time. So if that second difference is the same, it's either going up or down by 4. So that's when it's quadratic, is when that second difference is the same. Exponential's easy. Because exponential, you'll just see that it's getting multiplied.
By 4. 3.
This one's tricky. What is it getting multiplied by every time?
3.
Times 3. Do you see it? Exponential. So let's do one, and then you can try to do it. I'll do one, and then I'll have you try the other 5. And then we'll we'll do these 5 together, and then we got the next page up to 21. Sorry, I screwed up. No, I'm going to do up to 24. You're doing the next page. Okay, here we go. Ready? Tell me, what does this one do? Is it going up by this? What is it doing?
Linear.
Is it going up or down? Really?
Down.
Down by 2 every time. So when it goes up or down by the same amount every time, it's what? Linear. You see that? All right, next one. What does this do?
Being divided by 5.
Oh, that one's, you see it? So divided by 5 is the same thing as times 1/5. Divided by 5, same thing. So if you're multiplying and dividing by the same thing every time, so if you wanted to say divided by 5 every time, divided by 5, divided by 5, so is that an L curve or a J curve? Is it going up or down? L curve. Very good. Very good. All right, what about 21? Some people might say multiply by 5, but 5 times 5 is 25, but is 25 times 5 59?
No.
No, then let's see how much it's adding. How much is it adding? 30, then what?
24.
Is that 24, then what?
32.
Is that, are you sure it was 24?
Yeah, I'm thinking 34.
Is it 34? Then what?
38.
38? Now look, what do these second go up by?
Fours.
So when the second difference goes up the same, we call it what? Quadratic. After you figure out the pattern, the second difference, if the second difference goes up or down by the same amount, it's quadratic. Okay, 22. What does this one do? Is it adding, or is it getting multiplied by the same thing every time? Yes, multiplied by 4. So when it gets multiplied by something, it's exponential. So what is it, J curve or L curve? Is it going up or down?
J.
J curve. Or you can put growth if you want. You guys are doing awesome. Okay, 23. What's happening every time?
Times you.
I don't think so.
Plus minus.
Minusing what? Or adding? Which one? Add 7 every time.
Booty.
So what is it when you just add the same thing every time? This is the easiest one, the line. Linear. Last one, then I'll let you do homework. And you got like 15 minutes or 12 minutes.
Plus 12 on each one.
Plus 12. So what is it when it's plus 12 on each one?
1.
Linear again. Now, the next page, it's just the pictures. You just write down the first 8, you just write down what it is. The next 4, you just look at the graph and tell me what it is. And the last one, you kind of have to look at the table. So let's do 1 through 21 odds. How does that sound? The odds.
Bruh, I'm
So
almost done with the whole
1, it doesn't take long. We will end up doing them all tomorrow, but get the odds done before tomorrow, and then we'll go through all of them in class tomorrow.
Questions done.